Now what about going the other way? Starting with the graph and writing its equation. Let's start with the general formula. We have y is equal to a times either the sine or the cosine. Let's write the sine this time, of b times x minus c. There are going to be a number of different formulas we can use that represent the same graph. So we won't always have the same answer. If this is a multiple choice question, you can also try matching the given expressions, the given formulas. You can also try matching the given equations to the graph. In any case, to write an equation, we'll have to find a value for a value for b, and a value for c. Of course, that means we have to remember what each one represents. Of course, the amplitude is given by the value of a. The amplitude is the absolute value of a. What is the amplitude given in this graph? Well, looking at the y value from the midline to the maximum point, we travel a distance of 2.5, and from the midline to the minimum point, a distance of negative 2.5. So the absolute value of a is 2.5. We'll likely be able to use positive 2.5 in our answer. Now what about b? What is the period of the given graph? Well, to find the period, we can either go peak to peak, minimum point or trough to trough, or from the x-axis to another point on the x-axis, as long as the graph is traveling in the same direction. In this case, I think going from where we cross the x-axis to where we cross the x-axis, traveling in the same direction, is easiest, as it takes us from 0 to 6 pi. So here the period, 2 pi over b, is 6 pi radians. As I said, the period, we evaluate 2 pi over b, so we simply need to reorganize this portion of the equation to solve for b, to solve for the frequency. B ends up having a value of 2 pi divided by 6 pi, which is equal to 1/3. Now what about the shift? This is where it can get tricky. We can think of this as a sine wave that starts at the origin and ends at 6 pi. In that case, there is no shift and the value for c is 0. Alternately, you can think of this as a cosine wave, so starting at the maximum point, 2.5, and traveling in this direction. Let's have a look at both. If we assume that this is a sine wave, which is perfectly reasonable, we said that if this is a sine function, that the value of c is 0. In any case, we have a value for a of 2.5, and it is positive 2.5 since this is not a reflected sine function. It does start by heading towards the maximum first. A value for b of 1/3, and a value of c of 0. So our sine function is y is equal to 2.5 times the sine of 1/3 x, plus c or minus c, but c has a value of 0. If we assume that this is a cosine graph, also valid, we can see that it's actually a cosine that's been shifted. It's been shifted from the origin to this first tick mark. What is the value of the tick mark in between? Well, if we travel 2 tick marks from 0 to the second tick mark, we've traveled a distance of 3 pi. So halfway through, we must be at a distance of 3 pi over 2. So if we assume that this is a cosine graph, we have a value for c of positive 3 pi over 2. Positive because the graph of cosine is shifted to the right. That gives us a function that looks like this. Y is equal to 2.5, the value for a, times the cosine, 1/3, the value for b, times x, minus the value of c, 3 pi over 2. Both of those equations, this given equation, looking at it as a sine function, and this equation, imagining that we have a cosine function, both describe our graph. So they're both valid answers. Let's try another one. What do we see in this case? So once again, the general formula is y is equal to a times the sine or cosine, I'll use cosine this time, times b times x minus c. What are our values for a, b, and c? Well, the given amplitude here, if we measure from the midline to the maximum point, is 4, or from the midline to the minimum point, over here, is negative 4. So the amplitude has a value of 4. We're going to keep the amplitude as a positive value and not deal with a reflected graph. Again, there are going to be many equations we could use to describe this. We're going to try to use the most straightforward equation that we can. So if the amplitude has a value of 4, then we'll use a with a value of 4. What about the period? How long does it take to get through one cycle? Well, here it might be easiest if we measure from maximum point to maximum point. Though what I also notice is that both of these will be shifted the same amount from the tick mark to their left. We're told that this first maximum point is pi over 6 shifted to the right along the x-axis. So if we shift that back to 0, then of course this point will shift back to its previous tick mark, or 2 pi. I think we can see fairly clearly that the period of this function is 2 pi. What we'd like to find, of course, is the frequency. So the period we know is equal to 2 pi over b, and we solve this equation for b. Turns out that b is equal to 1. So we'll add that to our list. What about the horizontal shift? Well, we already discussed that one. We're shifting this graph to the right a distance of pi over 6. So the value for c is positive pi over 6. Looking at this graph, the one that jumps out at me most clearly, the one we've been discussing with its shift of pi over 6, must be a graph of cosine. So let's put all of that together. Gives us y is equal to 4 times the cosine of 1 times x minus pi over 6. Or to tidy this up a little bit, this is the graph of y is equal to 4 times cosine of x minus pi over 6. I'm sure you can come up with additional formulas, additional functions that describe the same graph. Let's do one more to make sure we've got this. What does this look like? Should we use sine or cosine to describe it? Well, I can clearly see one period, one cycle of the sine wave. So why don't we use that? Yes, it's shifted from the origin, but it's not shifted as far as cosine would be. If we think of this as a graph of cosine, we either have to start it here and keep going, or continue drawing this graph to the left and start at the minimum point. Either is a little bit more complicated than just treating it as a sine wave. So the general formula of a sinusoidal is y is equal to a times the sine of b times x minus c. The amplitude for this function is once again 4, so our value for a must be 4. And our value for a is going to be positive 4 because, again, we're starting the sine wave at the x-axis and traveling up first. So no need to give a reflected value here. The period for this function, well, for half of this function, I travel from 2 pi to 14 pi. We travel a distance of 12 pi. So if this is 12 pi for half of the cycle, then we must cross the x-axis 12 more pi later. There must be another 12 pi on this side. So altogether we have a period of 24 pi. Period is always evaluated by using 2 pi over the frequency. So we'll reorganize this equation to solve for b. And we find that b is equal to 2 pi over 24 pi, or just 1 over 12. So b has a value of 1 over 12. And finally, the horizontal shift. Here we see that we've shifted the graph based on our starting point from 0 to 2 pi. So we have a horizontal shift of positive 2 pi, where the value of c is 2 pi. Filling in the values for a, b, and c gives us y is equal to 4 times the sine of 1/2 x minus 2 pi. And once again, that's one way to describe the graph in front of us.